In this example, they want us to draw a 225-degree angle. So here we have the unit circle. The unit circle means the radius 1 circle. Unit means 1. So this is the circle of radius 1. See how the radius is 1? The radius is how far from the middle to the edge. You could go that way or straight up. It's 1, or left. It's -1, down to say 1. So the radius is 1 for this circle. It's the unit circle. We use it. It's convenient. You'll see why soon. So, and then we have a bunch of angles. Now we start 0 degrees right on the side. That's by common agreement. There's not a logical reason for that. They could have made 0 straight up, but they decided to make it straight to the side by common agreement in the math science world. And they made all the way around 360 degrees. Again, that was by common agreement, not logic, because when they first did angles, they estimated that we go around the sun in about 360 days. We have better estimates now, closer to 365. But back then they thought it was about 360, so they said, why don't we make all the way around a circle then 360 degrees. That was made up. And once that 360 is all the way around, then 180 is halfway around. And 90 is a quarter. This is 270 then. So it all just came from that. And so now the other angles that we use, is about convenience in trigonometry. Oh, let me do halfway. So halfway, this would be 45 degrees. And then 90 add 45, this would be 135. 180 add 45. So it's always 45 degrees to go halfway into a quadrant. This would be 225 degrees. 270 add 45 degrees. This is 225. So there's the halfway angles that are 45 degrees in the middle of each quadrant. And then to get the other angles that are close to the edges, the ones we use, I mean, they could have done anything, but you'll see why, especially in the next section, it's convenient for trigonometry, for sines and cosines, to be just 30 degrees off the edge. So this will be 30 degrees, and then this is 30 degrees off of 90. It's before 90, so it's less than 90, so it's 60. That's 30 before 90. And then this is 30 after 90, so this will be 120. This one right here is 30 before the 180, so it's 150. See how these ones closer to the edges are always 30 degrees from the edge. We use those because they're easy. You'll see in the next section. So this is 30 away from 180. It's more than 180, right? Add 30. This is 210. This one is 30 before 270, so it's 240. This one here is 30 past 270. This will be 300. Now this one, 0 is the same as 360, right? Because all the way around, again, they decided to make that 360. They could have made it a nice even 1,000 or 100 or whatever, but they decided 360, like we go around the sun, best estimate at that time. So if this is 360 all the way around, then this right here is 30 degrees before the edge, so this must be 330. So that's how those are the convenient angles we use for trigonometry. Here they all are in the unit circle. I'm sending you this so that you have it. It's all these angles laid out. It also has radians and sines and cosines, which we're going to get to. So that'll be convenient. Keep that in your notes for the homework and the exam as well. That'll help you and serve you well. So back to the question, what do they want me to do now? They want me to draw a 225-degree angle. Well, an angle always has two sides, doesn't it? Whenever you draw an angle, you know, it's an opening between two sides. Here is the first side, what we call the initial side, is already drawn for us, right? This goes from the origin out to 0 degrees. That's where they made 0 by common agreement. So where's 225? You can see it. It's right there. So therefore, that's all they want you to do. You just draw from the origin to the 225 spot. What we're saying is this opening is 225-degree opening. This is called the terminal side of the angle, the ending side, the starting side and the ending side. That's a 225-degree opening angle. So there we go.